Okay. Okay.
Uday ji, welcome.
Oh, thank you so much. Good
Thank you
morning,
for
everyone.
joining, sir.
So Aryan wants to present a talk on formation of elements.
Yes. So should I start?
Sure, go ahead.
Hello everyone. My name is Aryan, and for today our topic would be about how are new elements formed. Elements are formed through processes that occur in stars and nuclear reactions. Understanding these processes helps explain the diversity of elements in the universe. Today we will explore nuclear fusion, and the R&S processes of nucleosynthesis. What are elements? They are the building blocks of all matter in the universe. The periodic table organizes elements based on their atomic structure and properties. They are the simplest form of matter that cannot be broken down into anything simpler by chemical means. The origin of elements. Elements are created in stars through nuclear reactions. The processes depend on the star's size, temperature, and stage of evolution. These processes produce different elements and isotopes during stellar life cycles. Nuclear fission overview. So, nuclear fission is a process where a heavy nucleus splits into two lighter nuclei. This process releases a large amount of energy and additional neutrons. Fission is the principle behind nuclear reactors and atomic bombs. So, it is the process where a heavy nucleus absorbs another particle like a neutron, and it becomes way too heavy, and then it breaks down into two lighter nuclei, and that happens because there are way too many charges in that space. There are way too many protons in that space. That is why it splits into two. How nuclear fission works. A neutron collides with a heavy nucleus, such as uranium 235 or plutonium 239. The nucleus becomes unstable and splits into smaller nuclei called fission fragments. Energy neutrons and gamma rays are released during the fission process. So, whenever a very heavy nucleus, such as those of uranium 235 or plutonium 239, or those atoms which have too many protons, absorb another particle, such as a neutron, it becomes unstable and splits into two smaller nuclei. And it in rare cases it may split into more, and it splits into two because there are way too many protons in that close spaced. Nuclear fusion overview. So it is the process where light nuclei combine to form a heavier nucleus. Fusion releases enormous amounts of energy similar to processes in stars. Fission is considered a potential clean energy source for the future. So in this, what happens that lighter nuclei combine to form a heavier nucleus, and these processes happen in mostly stars where there is enough pressure to overcome the Coulomb's barrier. How nuclear fusion works. Two light nuclei, such as isotopes of hydrogen, deuterium, and tritium, collide at high speeds. When they fuse, they form a heavier nucleus, like helium, releasing energy. Fusion requires extremely high temperatures and pressures similar to the sun's core. When deuterium and tritium combined due to a nuclear fusion, it happened because it happens in the cores of stars where there is enough pressure and heat to overcome the barriers, and the sum of those will be greater than the uh, a new element form, that is helium, because some of the mass is getting converted into energy, and an neutron is also getting emitted. Fusion in stars. Fusion powers the sun and other stars by converting hydrogen into helium. The energy produced in fusion radiates outwards, providing light and warmth. Fusion in stars creates many heavier elements over their lifespan. Elements such as carbon and oxygen are also produced in stars. When when they fuse heavier and heavier elements, the radioactivity of the elements get lower and lower, and iron is the radioactive ash that is left, and after that they cannot fuse into other substances, and it gets collected at the core.
Good morning, sir.
Good morning.
The R process, rapid neutron capture. The R process occurs in environments with a high density of neutrons, like a supernova. Nuclei rapidly capture neutrons before they can decay, creating heavy elements. This process is responsible for forming many of the universe's heaviest elements, such as those like gold and platinum. So this happens in intense events like supernova or kilonova, and it is said that in a kilonova, the amount of about 10 earths are formed as gold and other heavy elements. So these are very rare events, but they are pretty effective, and this happens because the nuclei captures neutrons before they can decay during these intense events, and when that happens it becomes unstable and it converts the neutrons into protons, and that is how they are forming heavier and heavier elements. So this is the rapid neutron capture, where it captures neutrons at a very rapid pace, and then it converts those neutrons to protons. So that creates heavier elements. So moving on the next topic, the S process, slow neutron capture. So the S process occurs in aging stars during their late evolutionary stages. Neutron capture happens slowly, allowing beta decay to occur between captures. This process produces many stable isotopes of elements like strontium, barium, and lead. So in S process, what happens, that it happens in all of the old late evolutionary stages of a star. The an nuclei gets neutron at a very slow pace, and uh, and then they convert that neutron into the proton, which can produce many stable elements and many isotopes of elements like barium and lead. These two processes were founded by a female as scientist. Her name was Margaret, and the way she proved this was very interesting. To prove the S process, she pointed her telescopes at star and said if it has technetium and metal that is formed by S process, that will prove that these processes are correct, and that is how these processes were founded. So the differences between R and S processes. So R processes occur rapidly in explosive environments, while the S process is slow in stable stars. The R process creates the heaviest elements, whereas the S process creates lighter heavy elements. Both processes are essential for explaining the abundance of elements in the universe. So, uh, thanks, thank you. And the principles that R and S processes work on: beta decay. transfers neutrons into protons, allowing elements to climb the periodic table. In the slowest process, a decay occurs between individual neutron captures. In the rapid R process, captures overwhelm and decay, creating unstable heavy nuclei that eventually decay back towards stability. So most of the times, beta minus decay is happening where the neutron is getting converted into the proton, and it is producing beta elements such as antineutrino and electrons. In beta plus decay, in this what happens that the proton is getting converted into an neutron, and positron and neutrino are being produced. So they work on the principle of beta minus decay, where they convert neutrons into protons to make heavier and heavier elements. So thank you for listening, everyone. We are done with the presentation. Any further questions by anyone?
So, are there questions? Everybody has understood what Arian is saying. If there is anything which you haven't understood, you can ask him. Who is raising the hand?
Sir, everything was clear.
Sir Arthraj.
Earth is asking what?
No, sir.
Sir, I think so. He did it accidentally. Any further questions, anyone? Sir, do you have any questions about that presentation?
Yeah. So the first slide which you showed. Okay, I think okay. Do you know any process by which we do fusion also on Earth?
Sir, we create extreme environments to overcome these barriers.
Have you heard? Has anyone heard that? Is there can one do fusion also on Earth?
Yes, sir, I think so. There was something in China that had achieved fusion for 96 seconds. I've heard about it. It accelerates plasma.
Yeah. So that is called tokamak principles. Means you have a magnetic field, a toroidal magnetic field, in which what happens that you have the fusion elements are there, and
Yes, sir.
the temperature is made very high, almost that existing in the core of the sun,
Yes, sir.
and the fusion takes place. So that is one way. By the way, this one of the that is known as also you might read in the newspapers, ITER, ITER, which is done in France, and
Okay, sir.
India is also a part of it, of that development. And we have also tokamaks being built in Kolkata and in Ahmedabad, but they are smaller ones. So if you all get interested in future, so you can join this field because this is the upcoming field because we are looking for a fusion process.
Okay,
And
sir.
do you know where the fusion takes place on Earth
Patient.
or say in India?
Sir, if there is any heavier elements and if it strikes a neutron, it will just decay into two lighter elements.
No, but do you know any place where the fusion takes place in India?
In India, I don't have any idea about that, sir.
So all the reactors, they are built on the fusion principle.
Okay,
And we
sir.
have reactors. We have so many reactors in India. They produce about 8 gigawatt of energy, and all are based on the fusion, which is the uranium and the plutonium, which is used as the fuel. And that breaks and the energy is produced. But are you aware that is there any place in India where the new elements can be created?
Uh, Sir, I don't know any such laboratory.
Okay. Okay. So the one place is in Kolkata, of which I was a part. It is a cyclotron.
Yes, cyclotron. I
Yeah.
forgot.
Yeah. So a cyclotron produces heavy, high energy particles, and you can convert one element to the other element, but they are in very small quantities. So, and also there are many accelerators in India. So those are the places where you can join. And of course, you have the biggest accelerator, which is in Switzerland, CERN.
Yes, sir.
So there you can produce even quark,
Yes.
and you have the fusion process there, and the sorry fusion process also taking place, and the fusion also takes place. Basically, the fusion takes place there mostly. So, like say, gold nucleus collides with another gold nucleus, and many things happen. Yeah. So now we have a question from Earth. Yes, go ahead.
Sir, I have a question.
Yeah, go ahead.
Sir, if everything is made up of atoms, we haven't touched a single thing yet.
We have.
We have not touched a single thing yet.
You haven't touched.
Sir, he's talking that atoms cannot touch. We only feel the electronic push of things. So it means that we haven't touched anything in our lives.
Okay, yeah, yeah, you're correct. Yeah, we are not touching anything. Because
Sir,
nothing comes
but
closer. Like say, if you wish to put your hand on the nucleus of hydrogen, you can't do it.
सर इफ सर अगर हम किसी को मुक्का मार दे तो हम भी ये भी कह सकते हैं कि मैंने उसको नहीं
Oh,
मारा.
तब भी नहीं होगा. अच्छा, we
मैंने
have yes, we have one question from here. Her name is
Saksham.
Saksham. Yes, Saksham. What is the question?
Hello, Saksham.
Earth, Earth, please. Yes, your sound is background sound is coming. Earth.
Okay, sir. So I have a question.
You have also a
Yeah,
question.
Earth wants to
Okay,
ask a
okay.
question. Okay, okay. So Saksham, I am coming to you. Earth. What is the question?
Sir, what are the different types of rock and how they form?
Different types of
Rocks and how they are formed.
locks. LOCKS.
No, sir. Rock. ROCK.
Acha, rock. Okay, let us first finish the discussion on one topic.
Okay.
Then we come. And so, Saksham, what is your question?
So, sir, my question is what is PPC nuclear fusion and how does it affect stars?
I don't know why in my mobile it's. Please, can you repeat the question once again?
Sir, my question is what is PPC nuclear fusion and how does it affect a star?
Uh, Saksham is saying that what is a nuclear fusion?
No, sir, my question is what is PP chain nuclear fusion or we can say proton proton chain nuclear fusion.
No, we are talking about nucleus and nucleus. One nucleus with another nucleus. So what is the question?
Sir, my question is what is proton proton chain nuclear fusion and how does it affect stars?
Well, I'm not able to understand the question. उदय जी, आप क्या समझ पा रहे हैं क्या कह रहे हैं सक्षम?
Wait, sir, I'm typing it.
Hello?
Yes, Udayji, he is asking a question.
What's the
Something
question?
was. Yeah, can you repeat it once again, Saksham?
Sir, I have sent in the group. What is a proton-proton chain nuclear fusion and how does it affect the star?
Proton in nuclear fission. And how does it affect?
A star. I have sent this
A
question in the
star.
group.
A star.
Okay. Okay. So
Yes.
as far as there are two things, fission and fusion. I think you are clear about this. So there is no nuclear fission that takes place in star. Only nuclear fusion takes place in star. So I
Yes, sir.
hope you are. Go ahead.
No, sir. You can go ahead.
No, that's what I'm saying. There is no nuclear fission. Fission is breaking up. Fusion is joining it. So every time it's nuclear fusion which is taking place in star and not nuclear. Uh, sorry, fusion is taking place. Fu and not Fi.
Yes, sir. So I have heard about proton-proton chain nuclear fusion. So what does proton-proton chain mean in the nuclear fusion?
Proton chain in the nuclear fusion.
Yes, sir.
Uh, I really don't know what is this thing.
Because
Basically,
Saksham,
whenever the fusion takes place, it is by because of the proton only. Like the classic example is hydrogen protons. They merge together to form a helium. This thing, and what is released are other things like gamma rays, positron. Those things are released. So the basic fusion concept is based on proton only.
now I have a question to all of you. How does a nuclear reactor work? How do we get energy from a nuclear reactor? Who wants to answer this question?
Yes, sir, I can try.
Yeah, yourself, and who else is raising his hand? How many?
Sir, what? Can you repeat the question?
How does a nuclear reactor work? How do we get energy from a nuclear reactor? आजकल जो इलेक्ट्रिसिटी आपका जो पैदा होता है राजस्थान में, महाराष्ट्र में, they come from nuclear reactor. So how do we get this electricity? You want to try, Aryan? Nobody has raised his hand. So Aryan,
Yes,
what is your answer?
sir, when in nuclear reactors, we bombard a nucleus with neutrons so that when it
No, you bombard a nucleus means any nucleus will do, is it?
no sir, a particular type heavy nucleus which have a lot of protons, and if it gains another neutron it will get unstable and decay into two lighter
Yeah,
elements.
but so there are very few of them. Say uranium 235 is one.
Plutonium, yes sir.
So uranium 233 is one. So what happens? Neutron bombards. Then what happens?
Sir, because of the too many new proton charges in the nucleus, they split up into two, or
Hmm.
sometimes even more in rarer cases. So that too releases energy because the total energy of the two of the of the first nucleus is more than the than its byproduct. So, sir, that is how.
So Aryan, so one neutron bombards another nucleus.
Yes, sir.
So nucleus breaks. And
Yes, sir.
of course, no, the quite common is that many products are formed when it breaks. So, and
Yes, sir.
some
And
of them decay also and then form stable products. Okay,
yes,
so how do we get energy then? How the chain reaction takes place? You see,
sir.
आपने न्यूट्रॉन से तो बोmbard कर दिया,
Yes, sir.
तो फिर आगे वो बढ़ेगा कैसे? तब तो खिस्सा खत्म हो गया वहीं पर.
Sir, then the nucleus gets unstable, right?
Yes, it gets unstable, it breaks.
Yes, sir.
Then what happens?
Sir, then it splits up into two parts.
Yes, two, not two parts, many parts. Okay, right.
Yes,
Go
sir.
ahead.
It
And sir,
spreads. It
And
spreads
then,
the remaining things into many parts. You can say
yeah,
for the reactor.
yes. And then what happens? So how do we get energy? Means electricity कैसे आता है उससे?
sir, the extra energy at the we had more mass in the beginning than at the end, and that is why the mass created the mass turned into energy.
What energy?
Sir, photons. Sir,
No.
yes,
So,
sir.
so from photons, you cannot get electric energy, electric
Yes,
current, no?
yes, sir.
Acha, okay, I'm giving you some more hints that, okay, when say, usually such reactions are taken. Let us say one neutron bombards the nucleus and it should, for chain reaction, means it should generate now neutrons. So on the average, 3 neutrons are produced in case of uranium 235. So those 3 neutrons again bombard other nucleus and again that breaks. And from 3, you get now 9 neutrons. So that is how the chain reaction takes place. But
Yes,
that
sir.
still doesn't answer the question, how do we get electricity? Now, these fragments which are produced, they get such high energy that when they get deposited, they get heat energy, they produce heat energy. And then some fluid or liquid flows which get heated up because of this heat. And that heat again is converted like any thermal power plant into electricity. So are you aware that India, where are the nuclear reactors in India? How many of you know that? Where are the nuclear reactors in India?
Sir, in Kolkata.
No, unfortunately, eastern side doesn't have any nuclear reactor. We have an accelerator in Kolkata.
Sir,
Sir,
Nuclear
Chennai.
reactors are there
sir,
in Narora. Yes?
sir, sir, I think in Bhopal or something near it.
No, no, not in Bhopal. It is
Sir,
there one
Chennai.
reactor is in Narora, then in Chennai it is there, then in Maharashtra it is there, then in Rajasthan it is there. So
The total it is 25.
now I don't remember the total number now, but you have several reactors in these zones. We still do not have any reactor in the eastern side. So most of the reactors are located on the western side. So did you understand how a nuclear reactor works?
Yes, sir.
Earth, did you understand how a nuclear reactor works? Did you say yes? And Saksham, did you understand how a nuclear reactor works?
Um,
And
Sir,
yes,
now can you go on my question?
yes?
Now can you go on my question?
Acha, what was your question?
What are the different types of rock and how do they form?
Oh my God, but this I didn't know. I forgot. Of course, I read in the school. I don't know if someone knows. If Udayji knows,
I
maybe
think Parth
Uday.
Chowdhury is knowing.
No, but this is a thing you can get in your book. So what is there to understand in
Sir,
that?
given in book, sir.
Yeah, it is there in the book. If you say how
Yes,
many
sir, not
kinds of rocks
studying,
are
sir.
there and how they are formed.
Yes, sir, not studying, sir.
No, no. Let us take up those things which you don't understand in the school.
Yes, sir,
Then
not
we'll try to.
understand that only that how they form.
Yeah. So you didn't understand that, is it?
Yes, sir.
Oh my God! If Udayji can help you, if he can't, then I will read it and tell you next time. Udayji, can you?
What is your
He wants.
question?
His
What is
question is,
Okay.
how are the different types of rocks formed?
Yeah, so there are three types of rock that we talk about: igneous, sedimentary, and metamorphic rock.
yes.
So igneous is one which is formed because of cooling of magma, which comes from like what we see in Deccan Plateau or other places. The sedimentary rock is layer by layer sediments. Sediments they settle because of pressure, they get compressed and it is formed like sandstone, limestone, other things. What is Himalaya has a lot of sedimentary rocks also. Then we have metamorphic rock. What happens is when either the igneous sedimentary rocks, when they come under intense heat and pressure, then they form into marbles. Like they talk about Himalayas also, they're saying it's not because of colliding itself has happened, because at the speed and the pressure that's created, the rock started folding itself and pushing the Everest. So now because of that push, what was happening is enormous pressure is being created because of the friction, enough temperature is being created, and again we have metamorphic rock which get metamorphized where uh, the crystals gets crystallized because of high temperature and pressure. So what we have like marbles, granites, those types are generally of that type. Granites are also igneous rocks because of high temperature they are formed that way. But marble is generally metamorphic rock.
Sir, diamond is a mineral also and it is a gemstone also.
Some
Diamond is a
minerals
form
are
of
precious because they are called gemstones.
is a form of carbon.
No, sir. Some minerals are precious, known as gemstone, like ruby, topaz, opal, and diamond too.
Yes,
Diamond is
any
basically formed due to carbon. When we shape the carbon at the shape of diamond and we heat it under high pressure, then it will turn into a diamond.
so anything which is rare becomes precious. So precious gems and element and compounds are different issues. So in this particular case, diamond is an element basically, one type of carbon. And now to simulate the same condition which happens in the Earth's crust in a lab, you can create diamonds in the lab also. That's what they are trying to do, and they've been doing it for quite some time. And just to give an impression that the diamond which are mined are better, the same company started selling the lab grown diamond at a cheap rate just to try to give that impression. But lab grown diamonds are also produced under similar condition and they are supposed to be more pure as compared to the natural diamonds.
Sir, I have a question that we know that diamonds form due to carbon, but how does these diamonds form under the earth and how they do rise from volcanoes, preventing them from melting?
Crystals can't melt, sir, I think.
No, diamond is very this thing. Is diamond is an element. One of the way the carbon element is arranged, because of that it becomes diamond. Is the hardest substance. It can
Like the di-
withstand.
like the diamond is formed due to high temperature and pressure under the earth due to carbon. But how does this diamond survive the extreme conditions of the volcano and how does it rise due to these volcanic substances?
Type.
Sir, I have a question.
So it is not because of this, what you call it. It has to be a volcano which creates diamonds. It is because of the molten state where the temperature and pressure is high. They get compressed and they're made.
Yeah, but
Lot
probably
of
what he's
things.
saying, yes. So yeah, where there is a volcano, there won't be diamond.
Sir, I have a question.
But sir,
Okay,
it
so
is necessary that only the volcano will produce the diamond. Sometimes asteroid impacts can produce the similar reactions to form a diamond. Like in the case of
No,
Mercury, which is covered with millions, so billions of dollars of diamonds. So how does asteroid and volcanoes help to create diamonds?
Sir,
no, I'm not. Udayji, what is? I'm not understanding the question, but what I hope he's getting confused. No, volcano has nothing to do with it. You see, so we have got diamonds we got in Bhopal. There was no volcano there. We
No, so
have
not
diamonds in Africa where there was no volcano. So why you
no,
are thinking that the diamonds are produced in volcanoes?
no, sir, not in Bhopal. I have heard that when the volcanic eruptions occur due to the carbon and magma carried by volcano, if it rises to the surface, then due to the changing temperature, it might turn into the diamond. But sometimes asteroid impacts could also produce the formation of diamonds, like in the case of Mercury.
Okay,
Okay,
so I'll just try and clarify something is any any activity which can create a massive temperature and pressure, diamond is created. So you are right when if an asteroid hits and it manages to create a temperature and pressure which is similar to our Earth's crust, they are saying that the pressure has to be 4.5 to 6 gigapascal. Now we are talking about Earth's temperature pressure as 1013 heptapascal. So we are talking about gigapascal, which is around 45,000 to 60,000 more than atmospheric pressure, and temperature in excess of 900 to 1300 Celsius. So if anything can trigger that temperature and pressure, it will be formed. So even with asteroid hitting us, can create diamonds provided that reaches that temperature. Volcano and a diamond has nothing in common. What happens is lot of things, such things which are made because of high temperature and pressure are made in the Earth's crust. So what happens in whenever there is a volcano, lot of churning takes place. So lot of things which are under the crust, they get pushed upwards and they may be pushed. That happens. So if you find something somewhere, it's purely coincidence. Otherwise, volcano has nothing to do with diamonds. Diamonds are formed because of high temperature and pressure, which is found on the towards the center of the earth or towards the earth's crust. Did I manage to answer your question?
very nicely Udayji has explained to all of you, I think. See, nowadays the diamonds which are produced in lab, they are available in the market.
Yes, sir.
So when your sister or mother they go for marketing diamonds, tell them that you might get two kinds of diamonds, natural as well as lab grown, and they are same, nearly almost same. You can't distinguish.
Sir, I have a question.
But I have because the time is running short. I have just now, half an 1 hour back, I read that something about the induction. Induction, the oil is getting very scarce in the country. So you all should know about it. Have you heard about the induction cooking?
Yes, sir.
Uh, how many of you have heard induction cooking?
Sir, me.
Who else? Parth, have
Sir,
you heard induction cooking?
sir, I make food on inductions.
You made?
I make food on induction.
Oh, is it very good? So how does it work? Who can tell?
Sir, just plug it into the socket and then set up the manual and then
And it will start working. But how does induction work? Your food is getting cooked by induction? What is this induction?
sir buy electricity.
No, so by electricity, you see how does it come happen?
Sir,
Does
it
someone
yes, sir. Sir, it uses the heating effect of electric current. So it is evident in many other places, like in a heating rod, there is a coil of wire called the element, and that element is made up of nichrome wire. And whenever electricity passes through it, the electrons pass through it, It creates resistance, and that creates the temperature, which helps
First,
us heat the water.
Aryan, that's the principle of the electric heater, but not of the induction cooking. In
That
electric heater that you have, that is
yes,
the way it is done. But induction cooking is, based on the Faraday's laws. Faraday's laws, that
okay,
is the last time we were discussing, no?
sir.
That
It
if there is a magnetic field is there, and suppose you take a conductor, copper, let us say strip,
yes, sir.
and in that magnetic field you swipe, you move your copper, then in the magnetic field, if you move your conductor,
Yes,
it
sir.
will generate electric current in that conductor. That is what Faraday told us. So it
So
is based on the Faraday's laws. So
so
either way, or you can keep the conductor fixed and you can change the magnetic field, then also current will be induced in that. So induction cookers are based on that. So there is what happens is that there is a current, there is a, in the coil, the current is flowing, which produces a magnetic field. And the magnetic field, the you will find that all the induction, these utensils, they are very different. Their bottom is a little bit different.
yes, sir.
If you're using, you can go and have a look at it. You can't use your other pots in that. You need a special pots for that.
Yes, sir.
Those so they are, why they are special, because that is, there is a magnet at the bottom of those things. So what happens is that when AC current below it flows, and so there is a magnetic lines of force is there. So changing magnetic lines of force, which produces current, and that is called AD current. And because of this AD current, AD current, when the current flows, the heat is generated and your food gets cooked.
Okay, sir.
So you have to be
So
very, you must learn, you should go and have a look at it. Why also, you should be in your house. If someone is using a pacemaker, tell them not to go and stand near the induction, because there is a fluctuating magnetic field and that can affect the pacemaker. So
so
you
sir,
must, you are all bright students, no? So in the house, you must take care of things because you understand.
yes. So
So now the government now we are in India because people are running short of the gas.
yes,
So
sir.
people want to buy induction cooker, and it's very safe. It is much better than electric heaters.
Yes,
The
sir.
efficiency is much better. So you can tell your papa and mama, if you don't have induction, please buy one so that we can cook on that. If there is no gas, LPG gas, then we can use that.
So sir, I have one question.
Yes.
So what is the difference between torque and centrifugal force? I don't understand that.
No, Udayji, you want to say something about it? He's asking what is the difference between torque and centrifugal force.
Okay, so torque is causes the object to move in a rotation, that would change the rotation. Whereas centrifugal force is apparent force, which is felt by the object which is moving around the center.
So so sir, so what I understood that if we rotate, if I have a bucket of water and I rotate it in a circle, the water wouldn't fall because of the centrifugal force, because there is an opposite force acting on it, right? I
That's
think
correct.
so. And torque would be its ability to stay in the circular motion.
Yeah.
Oh,
Torque is that physical quantity that rotates the object.
and how it is produced?
Torque
Uh,
is basically the radius into force.
Radius into force.
It actually is a cross product. because you understand what is scalar and vector.
Yes, sir.
So and then you understand what is dot product and cross product. That
Okay.
means it should have a direction, the magnitude and direction.
Okay, sir.
So once you multiply two vectors, it becomes a cross product.
Okay, sir. So, sir, Earth has a question.
Acha, Aryan, but where did you learn about torque? What is this?
Uh,
What is, where did you learn about torque?
Sir, I had read about torque, uh, like in COVID time, and I thought I knew torque, but I actually didn't. I just confused it with centrifugal force. So that is why this question arose in my mind.
Another.
As you said,
So,
a centrifugal force and a torque can be they are interchangeable words.
no, what is in case of linear things, what is a force? In angular case, it is torque. So it is the equivalent of that. R cross F, which just now Udayji has told you. So in case of angular motion, rotational motion, you have got R cross F. The role which a force plays in a linear motion, the same role this torque plays in the rotational motion. And
Yes.
centrifugal force is a force, is an imaginary force, more or less. Now, suppose Earth is rotating around the sun.
Yes, sir.
A person sitting on the sun, he will say that we are exerting gravitational force on the Earth.
Earth.
So
Yes, sir.
he can explain the whole motion. There is a force is there,
Yes, sir.
gravitational. The person who is sitting on the earth, he will say that I am moving in a very nice way. I am not experiencing any force. So he will say that there is a gravitational force and there is a another centrifugal force opposite to it. See,
Oh,
there are only four forces in the nature. So centrifugal force is related to the frames of reference, basically how you are looking at things. So it is a
oh.
bit difficult concept, but I think maybe you can wait for a year or two, or s- or maybe next year. I think you will come across this.
So, can this centrifugal force be explained by using simpler terms, like on
No,
inertia?
no, there is nothing to explain. There are only four forces in the nature.
Okay.
So centrifugal force is a force arising due to the frames of reference.
Okay, sir.
Okay, I have told it very simply, but maybe someday I will take some time to explain more about it. There are too many. Only Earth is asking a question.
Yes, sir.
What is your question, Earth?
So which simple machine was invented first and which simple machine was discovered first?
Oh my God, it's a very difficult question, by the way.
What is the
It's a very.
question?
He's asking which is the simplest machine, which when was it discovered?
I don't know. It's exact thing we can't say, but liver, another thing must be the simplest one. Lifting heavy object.
No, sir, my question is not that.
Which is the simplest machine,
No,
isn't it?
sir.
Yeah. Then
Which simple machine was invented first and which simple machine was discovered first?
Invented first was liver and discovered first was wheel and axle.
Explanation.
it's a
When early humans saw leaf rolling from the mountains, they found the idea of making logs into parts and make a cart, put a cart on it, and ride over it. Then, then they, then they, then they cut the flat surface of the logs and made a wheel and axle. And invented first was lever. The discovery of lever was made in lab only when they were pulling something up and down.
Okay, this is one answer. I have also one answer. I think the first machine was the arrow.
No, sir, he
Uh,
asked the first simplest machine like
yeah,
that.
the simplest machine like is an arrow.
Okay.
Arrow in the sense that by making it pointed, you are exerting more pressure on a small area, so that penetration is more. So
Yes.
when human beings learned how to use arrow, they started killing fish, they started killing animals. But before that, they didn't know how to kill a fish also. Well, this is my opinion. You might differ from it. Maybe Udayji might have another answer. So,
No, no, what you're saying it makes a lot of sense because I never thought about this. I've only thought about that. Okay, when people started lifting objects, the liver is the most common example that comes
right,
into mind.
right. Yes.
Yeah.
Acha, now Parth has a question. What is the question, Parth?
So why we throw a ball on the ground and it's bounce? Why it just stay there because of the gravity?
Who wants to answer this question?
What is the question?
Why a ball bounce on the surface, but why it's not stay there because of the gravity?
Did not understand your question, Path.
No, I'll make you understand. He's asking that suppose you throw a ball from your hand, then it reaches the ground, then again it bounces back. Why? He's asking. Who wants to answer this question? This one is asked by Parth, isn't it?
Yes, sir.
So,
It
Parth, what
depends.
is the answer to this question? Do you know it?
No, sir.
You don't know it. Okay. So, Saksham, do you know the answer to this question?
Yes, sir, I am giving. It depends on the size and the speed and the composition of the ball. Suppose I have a sponge ball and I drop it on the ground, like in cement ground, then it will go jump and then fall back because it is made of rubber and some lightweight particles. And if there is an iron ball and it will, and suppose it is placed on a grassy ground, then it will jump again because of the force exerted by the force of nature, we can say gravity and the composition of the ball. So
So
But
can I
why
say?
it bounce? It should be stayed there only because of the gravity.
So can I say?
Yes, yes, please go ahead.
So ball bounces instead of it staying on the surface because of elasticity and energy transfer, not just gravity.
Oh my God, very difficult answer. As I'm not able to make out. So, what happens when a ball comes down? So,
Sir,
surely there must be because it comes with a velocity. So, there must be, a little bit of compression ball might experience. And again, when that is released, it goes up. Means the energy gets there.
yes, sir. Sir, he has an
Like
answer.
say, suppose you have a hello.
Yes, sir.
Yeah, Earth has an answer. What is that?
No, sir, I have a question.
Oh, you have a question.
Yes,
No,
sir.
but first you have to answer why the ball comes up. Well, let this be a homework for all of you. Next time you must tell us.
So, sir, I have one more question. When he asked the question, another question arose in my mind. So, when we pull a spring and it bounces back, how where does it get the energy, and how does it bounce back? Is something special with its molecular structure? When we sir, did you get it?
So you're telling when we stretch the spring and then again when we leave it, it comes back. That is what
Yes,
you are saying.
yes, sir.
Yeah, who wants to answer this question?
Aryan, can you repeat your question in simple words?
He's saying that suppose there is a spring and you stretch the spring, and if you leave the spring, suddenly it comes back to the original shape. Why does it come to the original shape?
Hmm.
Okay, so this is the second question. Maybe this can go as for the homework, for your homework.
Sir, can I try
Let us.
this question?
You want to answer this? Yes, sure. Please go ahead.
Sir, I think that is because of the Hooke's law.
What is Hooke's law, by the way? Amarnath ji is there, you see. So that's a very engineering concept, Hooke's law.
Sir, Hooke's law states the elastic limit, the stress applied to a material is directly proportional to the strain produced and expressed as a strain or a stress. Its
Yeah,
formula is
Hooke's law says stress and strain, but what is stress and what is strain?
Like, what is special in the in that material that it bounces back? Is something unique with its molecular structure, or what? Yes, sir.
No, of course, something must be happening at the molecular level.
Yes, sir. I was also thinking about that. It must be the molecular structure.
No, no doubt about that. But how do you explain it?
Yes, sir. Sir, there may be special bonds between those molecules. So when we pull, they try to get together more harder. So that can be one of the solutions.
You could think of in this way that when you stretch it, so you are making the molecules, molecules must be getting away from little bit away from each other.
Yes, sir.
And so again, the force will bring it back. That is what it means. Basically, that is what must be happening.
Oh, okay, sir.
So, so when you stretch it, there is a bit of reorganization of the molecules, and there are forces between the molecules there. So again, that brings it back. So again, it comes to the original position.
Okay, sir.
This is the process that it happens. Now, Earth has a question. What is that question? Hello, Earth.
Yes, sir.
You had a question.
Yes, sir.
Is it Earth or is it Saksham is having a question?
No, sir. I.
Acha, okay. Earth is having a question. What is that question?
Sir,
No, I
I
want you to
have.
ask. No. I want you to ask a question after you have discussed in your mind, and then you fail to understand. Then you should ask it.
Sir, I
Otherwise, there will be thousands of questions. I have thousands of questions I can ask. I can read a book and start asking question from one chapter to the next chapter. but that is what we'll be wasting our time. You should ask a question which you think that you have worked on it, and then you fail to understand, and then you
Yes,
should
sir.
ask.
Yes, sir.
So go ahead.
I have asked it last time also, but anyone not answered.
Oh my God, I'm sorry. Yeah, please, can you repeat it?
The question is a stone is dropped from a height of 80 meters from the surface of the earth. How long will it take to reach the ground? And what will be its velocity just before hitting the ground?
So, so there are formulas are there, and last time the girl had come. No, she told that she is going to explain to us.
Yes, I
What's
can
this?
also say that you can take gravity 9.8 second.
Yeah. So so you see, there are three formulas are there, and you can use those formulas. One is v square plus u square is equal to twice a. V square is equal to u square plus twice a into s, the distance which is there. One is v is equal to u plus ft, and one is s is equal to ut plus half ft square, where f is the acceleration due to gravity. T is the time, S is the distance traveled. So using all these formulas, you can answer those questions. But we had given this as a homework to you. And now you're asking me now.
Sir, she didn't come, the girl.
Oh, she didn't come. Yeah, I don't see her.
So
Yeah.
Earth Apeksha is here or no? You want to say something regarding this?
No, no. But Earth, no. So these are the three formulas which are used. And you can find anything about if you draw all the questions related to the falling ball and things like that.
So, Earth, you remind Apeksha that she has to come back and report on this homework.
Yeah.
Yes, her homework is pending.
Yeah.
Yeah.
And sir, today no one new student also joined. Yes, others, please say something about yourself. I think it is first time in this session. Others,
Yes, sir.
Yeah.
please say something about yourself.
Okay, sir. My name is Jadesh Kumarja. I am 11 years old. I read in class. My father name is Mr. Siddhartha. My mother name is Mr. Primary School. Sir,
Your voice is not clear. Your voice is not clear. Can you repeat it?
okay, sir. Why should we understand?
A bit louder, please. Yes.
Okay, sir. My name is Adarsh Kumarja. I am 11 years old. I read in 5th class. My father name is Mr. Sudirja. My mother name is Mrs. Sapnadevi. My school name is MCD Primary School. My teacher name is Aarti ma'am. My favorite color name is red color. I have done, sir.
No, we are not interested in you. What is your favorite color? But which class did you say? Class 5? Class 5 or 7? Hello?
Yes, sir.
Did you class 7 or class 5? Class?
Sir, class 5.
Acha, class 5. Okay. So what is your favorite subject?
English.
Oh, you don't like science? Science and mathematics?
Yes, sir.
So when you grow big, what do you want to become? Hello?
Yes, sir.
When you grow big, what do you want to become?
I
Okay.
think they left it. Or it's
Okay. Okay. So Saksham has a question now. Saksham. Hello, Saksham. Please ask the question.
Yes, yes, sir.
Yes.
I have a question.
yes, others.
That if the
1 second.
diameter of the black hole is one, if the mass of the black hole is 147 times more massive than the sun, so its diameter will be 867.6 kilometers. But we use gravitational constant. So how does this gravitational constant help us to find the diameter of the black hole?
Um, no, how is it? No, gravitational constant is a gravitational constant. That is a constant. So I am not getting that. Why you're asking that? How it has been used to find the mass of the black hole? Can you explain to me the question, or has someone understood the question?
So my question is
A bit
that
louder. Actually, your voice is very soft. Yes, a bit louder.
sir, if the mass of the black hole is 147 solar masses, then
Yes.
its diameter will be 867.6 km with the help of gravitational constant, whose formula is 6.674 into 10 to the power minus 11 m q kg to the power minus 1 to the power to the power minus 2. So how does this gravitational constant helps us to find the black black hole's radius and diameter?
So, sir, I can try. So,
No,
there is
no, no. But I want to understand the question. Why does a gravitational constant help us to find the mass of black hole? Gravitational
No,
constant is gravitational constant.
it is
sir,
required.
not
Yes.
mass, radius and diameter.
Yeah. So there are formulas which involves gravitational constant between the
But sir,
mass and the radius. There is a formula. So
if
yeah,
the black hole even
that is
like
what
the
Aryan wants to say. Yes. Last time he had given this answer. Aryan, can you repeat the answer once again?
So, sir, we can find the radius of a black hole by the Schwarzschild equation. It was, I think, so 2 gm divided by c squared. So we multiply 2 gm, which is the gravitational constant, times the mass of the black hole, and multiplied by 2 and divided by c squared. And then we will get the radius, and to find diameter, we can just multiply the radius.
but if the black hole is 20 or 10 times the mass of the sun, so we will not use this gravitational constant.
Why?
Sir, because according to Schwarzschild radius rule, if the mass of the black hole is 10 times the mass of the sun, so we will use the Schwarzschild radius of the sun to find the diameter of the black hole. But if the black hole is much larger, then we use the gravitational constant. So sir, why don't we use gravitational constant if the black hole is much smaller?
I didn't understand.
I'm not. I'm also not understand. No, gravitational constant is a gravitational constant. So wherever the gravitation is there, you have to use the gravitational constant, which is a fixed quantity.
No, sir. Suppose there is a black hole which is 10 times. So we will use the Schwarzschild radius of the sun, which is 3 kilometers. And due to that Schwarzschild radius of the black hole, which will be found is 30 kilometers, we will find the diameter of the black hole, which will result 60 kilometers. But if the black hole is much larger, 140 to 150 times more massive, then why don't we use this Schwarzschild radius formula to find the diameter of the black hole?
Schwarz, we use this Schwarzschild radius formula for all the masses of black holes, including the lower and higher ones.
See, the formula which you are referring to is calculated by what is the gravitational force which is required, means what will be the size of a
Yes,
body so that the
traps.
a for, something with a velocity of light can never leave the surface of that black hole. So that is how the radius comes. So that is the black hole radius. So there is G everywhere. No, but are you telling that the G is not what Saksham is telling, that if the mass is 147 times, then we can't use the gravitational constant. Well, I haven't heard about that. Are you sure about it, what you're saying?
Yes, sir. I have seen the formulas of this mass, and I don't seen this gravitational constant to other masses.
Let me just check. I will come back to you. If you have seen it, I will also see it. Maybe Aryan, you also check
Yes, sir.
that
I've
if the
checked.
mass is 147 times, then this G cannot be used. Is it true?
No, sir. If the mass is 147 times, then we use G. But if the mass is 10 times, we don't use G. Why is it
Yeah,
so?
okay. The reverse you are saying, right? Okay. I'm not aware about it.
Sir, I think I have searched for the lower and higher masses. We use the same Schwarzschild formula, 2 gm divided by
So,
c squared.
so with the same G value.
Yes, sir.
Yeah, that is what I also think so. But then since he's telling, even last time he said, and then this time he's saying, so I will do a bit of research and come back to you. Or if Udayji wants to say something about it. Udayji?
Yeah, actually, I agree with what Aryan is saying, that the formula is standard. I have not also come across any
Yeah, but
distinction between different black holes. So it is the same, two times the gravitational constant times the mass of that black hole divided by square of the speed of light.
yeah, but Saksham is, even last time he said, and then this time he's saying that it is not used if the mass is only 10 times.
So I was, yeah. So actually, when he's insisting, I actually will trying to look on this. He says
Yes.
that even if the some ultra massive black hole they're talking about 10618, it is about 66 million times the solar mass
No,
and has a
sir.
radius of what, 194 billion kilometers or 1300 astronomical unit. That is the distance uh, between sun and earth. So even if you consider that they are following the same source of what is called short slit formula, so there is no difference in that particular case. So even for large ones, he is only saying 10 times. I'm talking about 66 million times the sun's mass. 66 billion, b with letter b, billion.
Saksham, I have a question for you. So you know what is your mass? What is your mass, by the way? Hello, Saksham.
Yes, sir.
What is your mass?
Sir, my mass is closer to some 50 kilograms.
50 kilograms. So
Yes, sir.
next time you tell me, next time when you come, so this 50-kilometer mass, so what will, suppose we squeeze you and your radius becomes less. So what will be the radius that you will become a black hole? Can you calculate it next time and come?
For me to become a black hole, I need to be much smaller than an atom.
Yeah, so I want to know what should be your radius that you will become a black hole.
Sir, I think it would be some picometers.
So, sir, it would be
How?
like something uh, 30 times 10 raised to the power of minus 11 divided by c squared, around this figure.
Yeah. So no, do the exact calculation and tell me next time so that we'll know when Saksham can become a black hole.
Oh,
Sir, If an object is 70 kilograms heavy and it needs to be 10 times smaller than a hydrogen atom to become a black hole, and for me, I need to be 15 times approx.
So 15 times the radius of the hydrogen, is it?
No,
So
50 times smaller.
oh, 50 times smaller than the hydrogen atom.
15,
Yes,
yes, sir.
sir.
Okay, put the right figures and come next time, actually. We will
Yes.
know then.
Okay, sir.
So now is it time to say goodbye to all of you? Or
Yes.
do you have some questions? So tell your parents that if you don't have gas, please buy induction cooktops.